Okay, let's unpack this. We're doing a deep dive today into something that, well, it looks poised to really shake things up for building with LLM.
Hmm.
It's called the Model Context Protocol, MCP for short. And our source here is a pretty significant report that just came out this month, May 2025.
Right. And our goal really is to walk you through what NCP actually is, why it's cropping up now as, yeah, potentially a game changer.
And how it's trying to shift LLMs, well, away from being these sort of opaque black boxes, you know?
Exactly. Towards something that feels much more like inspectable software, the
Yeah.
software you could actually manage.
That idea, controllable software instead of black box,
Yeah.
that really seems to be the heart of what this report is getting at. Because let's be honest, building complex stuff with LLMs right now,
Yeah.
it often feels a bit like you're, I don't know, hacking something together.
It absolutely can. The report puts it quite well, I think. Traditional prompting, it's powerful for simple things, sure, but it hits a wall pretty fast for complex, real-world stuff.
Right.
It just doesn't have the clarity or the scalability. And definitely not the safety controls you'd expect from, standard software engineering. Debugging is painful.
Oh, yeah. And getting the same result twice. Good luck.
Exactly.
Yeah.
Reproducibility is kind of a toss-up.
Okay, so if prompting is like wrangling this unpredictable thing, MCP's approach, the report says, it's totally different. It's about modularity.
Modularity, precisely. Instead of one giant prompt where you're just hoping the model gets it right, MCP says, let's break down the complex job into smaller steps and have these like cooperating LLM agents or modules handle each step.
Okay, modules. And the report gets specific, right? Like there's a planner module.
Yes, the planner.
Yeah.
Its job is to look at what you asked for, the user request, and basically map out the sequence of steps needed to get it done. It creates the plan.
Okay, makes sense. Then a retriever.
Right. So the retriever reads that plan, sees what info is missing, what data it needs from outside,
Got it.
and goes and fetches it, whether that's from your company docs, a database, maybe the web.
And a coder module. What's that for?
The coder is there to actually generate, well, code or any kind of structured logic that the plan calls for. It turns the task into something executable.
And presumably an executor to run that code or logic?
You got it. The executor takes the output, maybe from the coder or another module, runs it, and this is important, feeds the results back into the system.
Ah, okay. So other modules can use that new information.
Exactly. It keeps the process moving forward based on what just happened.
And all this back and forth happens through, what do they call it? A shared memory or a call stack.
Yeah, and that's where it starts feeling much more like traditional software engineering,
Yeah.
This shared structure, it acts like a central hub.
Like a whiteboard.
Sort of, yeah. Or maybe like a really structured log. Modules read instructions from it, they write their results back to it, and it keeps track of the whole process state. It's all transparent.
Okay, that transparency, that structure, it really highlights the differences the report draws between MCP and just, standard prompting.
Huge differences.
Like design philosophy. One giant implicit prompt versus these explicit modular workflows.
Right, and that difference cascades down. Think about debugging. Instead of guessing why your massive prompt failed,
Which is awful.
yeah, you get step-by-step traceability. You can see which module failed and why based on the interactions logged in that shared memory.
And auditability, too, goes from basically nothing
Right, no real logs,
to a clear history of every step taken by every module.
which is crucial for some applications.
Yeah.
And control. With a single prompt, you have very little fine-grained control.
Mm-hmm.
With MCP, you can tweak, customize, even swap out individual modules if one isn't working well enough.
And reuse, that's a big one in software.
A huge one. You can build and test these reliable little components, these modules, and then plug them into different workflows. Try doing that easily with a giant monolithic prompt. It's hard.
Okay, speaking of predictability, or lack thereof, the report talks quite a bit about sampling in LLMs. Can you break that down? Why is it so central here?
Sure. Sampling is. It's core to how these models generate text. When an LLM predicts the next word or token, it doesn't just pick the single most likely word every single time. It actually draws from a probability distribution. There's a whole set of possible next tokens, each with a probability.
So it's probabilistic, not deterministic. Like same input doesn't always mean same output.
Exactly that. It's like it's rolling dice for the next word, but the dice are weighted based on the probabilities it learned during training.
Okay.
And the report makes this really critical point. Sampling from the model is not the same as reasoning.
Right. What does that mean exactly?
It means the model is good at generating a sequence of tokens that looks plausible based on patterns it's seen. But it's not necessarily following a strict logical chain of deduction step by step. It's pattern matching and probabilistic selection.
And that's a problem for complex tasks that do need strict logic.
Precisely. Plausible isn't always correct or reliable, especially for multi-step processes. And this is where MCP comes in, according to the report.
How does it help with the sampling issue?
Well, by breaking the big task into smaller, well-defined steps
Yeah.
handled by these specialized modules,
Right.
you're reducing the reliance on one giant model's unpredictable sampling for the entire complex process. You can isolate where that probabilistic sampling happens.
And maybe use more deterministic logic or smaller, more focused models for certain steps?
Exactly. You can structure the workflow around the sampling, contain it, and use more reliable methods for critical parts. Makes the whole thing less prone to just randomly going off the rails.
Okay, that makes sense. So let's talk bottom line. For businesses, for people actually building apps, what are the benefits the report lists?
Well, trust and governance is a big one. Those inspectable steps, the logs, that's huge for regulated industries, finance, legal, healthcare.
Non-negotiable, really.
Totally. Then there's potentially reduced cost. You don't need one giant, super expensive model for everything. You could use smaller, cheaper models for simpler module tasks.
Ah, mix and match.
Yep. Custom logic is easier to plug in if you have a proprietary way of doing one step, make it a module. Debugging, as we said, is way friendlier. Retry just the failed part, not the whole thing.
That saves time and compute.
And it's designed as an open source, extensible protocol.
Okay, the use cases they mention really drive this home, like a multi-step dev assistant.
Yeah, instead of just write this code, imagine. Planner breaks down the task, retriever gets the API docs, coder writes the code, executor runs the unit tests, another module formats the pull request.
All logged and traceable.
Exactly. Or think about legal and compliance. Breaking down a complex legal query. Retriever finds relevant case law. Another module drafts arguments with citations. A validator checks compliance rules. All transparent.
Enterprise knowledge agents, too, not just finding documents, but planning a report structure, retrieving specific data points, drafting sections, verifying facts.
Building traceable reports step by step. And data pipelines, planning the ETL flow, querying database schemas, building the transformation code, verifying it. It's managing the process.
It really feels like it's trying to bring solid software engineering practices into the AI world.
Absolutely. Modularity, clear logs, interpretable errors, reuse, testing it aligns with principles we already trust.
And that point about using different models for different modules is key, isn't it?
Crucial. You can pick the best tool for each specific job, whether it's a small LLM, a big one, or even just traditional code for a deterministic step. You're not locked in.
So adoption. The report mentions it's open, community-driven, Hugging Face is involved somehow.
Yeah, it's positioned that way. It's still early days, the report notes, but it's out there, publicly accessible.
Okay.
And it's important to understand it's presented as a protocol defining how agents communicate, not really a framework like, say, LangChain or True AI that dictates exactly how you build the agents themselves.
Ah, so it's about the communication standard between potentially different systems.
Exactly. The goal seems to be neutrality and composability. It wants to play nice with other tools, retrieval systems, APIs, evaluation frameworks, whatever you need.
Okay. And the future vision presented. What's the bigger picture?
The vision seems to be a shift towards AI systems built from these composable interacting agents, which, they argue, is necessary for better governance, safety, and the kind of scalability you need for real product-grade applications.
Moving beyond just prompting and hoping for the best.
Pretty much. It's offering a more structured, engineering-focused path to building AI you can actually rely on for important stuff, mitigating some of that randomness from pure sampling.
So if you're listening and this sounds interesting, especially on the technical side, where do you look the report points to?
Yeah, it's open source, hosted on Hugging Face. You can find the MCP GitHub repository and the user guide there. It's definitely geared towards developers and researchers right now.
Right. So if you felt that friction trying to build complex, reliable things with LLMs, this MCP approach is something to maybe keep an eye on or even explore.
Definitely presents a different way to think about structuring these systems.
Which kind of brings us to a final thought, something to chew on from all this. How does fundamentally changing our perspective thinking of AI, not just as one big smart model, but as a structured system of interacting components, how does that change the way we design, trust, and actually deploy these technologies, especially in critical applications?
It really could be a significant shift in how we approach AI engineering moving forward.
Thank you for joining us today. We're here to share insights and ideas. Your support means everything. If today's discussion sparked an idea or helped you, let us know. Drop us a line, leave a review, and visit AgentFarm.com for more tools and insights. Until next time, stay inspired.